Hi students, how are you? I hope all of you are fine, right? Okay, in this session we are going to discuss about practice question number 11. Okay, so let's read the question. Find the number which divides 615 and 963, leaving a remainder 6 in each case, right? So find the number which divides. Okay, so when you read the question, you have to carefully analyze what the question is asking, right? The question is asking a number which divides. That means you are going to find the divisor, correct? When the question is asking you to find the divisor, you have to understand you have to find HCF, right? If the question is asking you to find a big number, that means the dividend, okay, then you have to find the LCM. Clear, students? See, LCM is the multiples, right? Least common multiples. Multiples will always be multiplying and it will be always a bigger number, which will be the dividend. Okay. HCF is the smaller number than the given numbers always, right? The name is highest common factor, but the number is small. Okay. So when the question is asking you to find the divisors, you have to find HCF, and when the question is asking you to find the bigger number, dividend, you have to find the LCM. Okay, this is the clue you should keep in mind. Okay, now given numbers are 615 and 963. Okay, but when you are dividing with that divisor, it will leave a remainder 6. Okay, so first we have to find out that number by reducing 6 from 615 and 963. Okay, let's start. So given numbers is equal to 615 and 963. Okay, now our required number will leave 6 as a remainder when you divide these two numbers, right? So you can find the required numbers. Required numbers is equal to 615 minus 6 and 963 minus 6, which is equal to 609 and 957. Okay, these are the two required numbers. Okay, now you have to find the HCF of these two numbers. Okay, to proceed to HCF, first we have to prime factorize 609 and 957, right? So let's start prime factorizing 609 first. Okay, so 609. Okay, so 2 will not divide as the last digit is odd digit, right? Okay, now let's go to 3. The divisibility rule for 3 is sum of the digits divided by 3 means 3 will divide, right? Let's check 9 plus 6 is equal to 15. 15 will be divisible by 3. Okay, so let's start with 3. So 3 2 times, 0, and 9 3 times. So 203. Okay, and 2 will not divide this number, 3 will not divide this number, and the sum last digit is 3, so 5 will not divide. And coming to 7, so the divisibility rule for 7 is double the last digit and then minus from the rest of the digits. Okay, double the last digit, 3 to 6, balance numbers are forming 20. So 20 minus 6 is equal to 14. 14 will be divisible by 7, so 203 will be divisible by 7. Okay, so let's start with 7. 2 times 7 14, balance 6 63. So 9 times 7 is equal to 63. Okay, so 29 is the prime number, so we can stop with this and we can write here 603 is equal to 3 into 7 into 29. Clear, students? Okay, now let us prime factorize 957. 957. See, the last digit is odd digit. 2 will not divide. And last digit is not 0, not 5. So 5 also will not divide. Okay. Let's check for 3. Okay. Check the sum of the digits. 16 plus 5, 21. 21 will be divisible by 3. So 957 will be divisible by 3. Okay. 3 times, 1 time, balance 27. 9 times 3 are 27. 3, 1, 9. Okay. Again 2 will not divide. Let's check for 3. Find the sum of the digits. 3 plus 1, 4. 4 plus 9 is equal to 13. 13 will not be divided by 3. Okay. So and 5 will not divide this number. Let's check for 7. Okay. The rule for 7, again take the last digits, double it and minus from the rest of the digits. Okay. So here 9 last digits, double it, 18. So 31 minus 18 is equal to 13. 13 will not be divisible by 7. Okay. So let's go to 11. Okay. So what is the divisibility rule for 11? Sum of odd digits and sum of even digits minus. Okay. The difference between the sum of even digits and sum of odd digits should be either 0 or it should be divisible by 11. Right. Let's check that one. Take 319. 3 plus 9 is equal to 12. 12 minus 1 is equal to 11. 11 will be divided by 11. So 319 will be divisible by 11. Okay. Take 11. 2 times 11s are 22. 99 9 times. Okay. So 29. So 29 is the prime number. So we can stop this factorization with this. Okay. Now we can write 957 is equal to 3 into 11 into 29, right? Okay. Now we have prime factorized the required numbers 609 and 957. Okay. Now we can find the HCF. For HCF, take the common factors. 3 is common here, 3, and 29 is common, right? Okay. Only 3 and 29 are common factors. Okay. So 3 times 20, 60. 3 times 9, 27. 60 plus 28, 27 is equal to 87. Okay. So HCF is equal to 87. Okay. So the number which divides 615 and 963, leaving a remainder 6 in each case is 87. That should be your answer. Okay. So we can write the answer. The number which divides 615 and 963, leaving a remainder 6 is 87. That is the answer. Clear, students? So what we have done, we have taken the given numbers and minus 6 from them, so that you will get the required numbers 609 and 957, and then prime factorize 609 and 957 and find their factors, and then find the HCF. The HCF will be the answer for this question. Clear, students? Hi, students. Now let us see the practice question number 12. Okay. Find the LCM of 2.5, 0.5 and 0.175. Right. You can see it's a different question, and in this class you are going to learn 2 new formulas. Okay. Right. Let us see. Okay. So these are all decimals. Right. See, as you have studied the rational numbers and irrational numbers, right? Types of real numbers, there is a video, scroll up video, go to that video, watch that. Okay. So you will have a clear idea of what is a rational number, what is irrational number, and what are all the nature of rational numbers and irrational numbers, what are all the decimal points and types of decimal points, everything. Okay, now you can see here, these are all the numbers having decimal points, right? 2.5, 0.5 and 0.175. Okay, these are having the terminating decimals, right? So terminating decimals are rational numbers, correct? Okay, now this is also rational number. Okay, so what are all the characters, identities of rational numbers, right? First, a rational number is a number which can be written in the form of a divided by b, right? First condition is it should be in the form of, or it should be able to write in the form of a divided by b, right? And second one, if it is a decimal, right, it should be terminating decimals. Okay, okay, if it is not terminating, it should be with repeating nature. Okay, point number 3, repeating nature, right? These are all the 3 points you should keep in mind when we are talking about the rational numbers. Okay, point number 1, it should be able to written in the form of a divided by b. Second one, it should always have terminating decimals. If it is non-terminating, then it will be repeating nature. Okay, this repeating nature is for non-terminating. Okay, okay, right. Now you can see here it's with terminating decimals, so this can be written in the form of a divided by b. Okay, so we will convert this decimal in the form of a divided by b form. Okay, before that, let us see the formula, which formula you have to use. Okay, right. See, the question is asking LCM, right? So LCM of rational numbers is equal to LCM of numerators divided by HCF of denominators. Yes, students. See, first we have to convert these given decimals into a divided by b form. Okay, and then you have to apply this formula. LCM of rational numbers is equal to LCM of numerators divided by HCF of denominators. Okay, now let us see 2.5, 0.5 and 0.175, how to convert into a divided by b form. Okay, as you know well, 0.5 can be written as 1 by 2, right? Okay, 0.5 is equal to 1 by 2, and 0.25 can be written in the form of 1 by 4, and 0.75 can be written in the form of 3 by 4, right? In the same way, we are going to convert this. Okay, so 2.5, we can write 25 divided by 10. Okay, that means, you see, 2.5 multiply with 10, and in the denominator 1 is there, right? We can multiply with 10. So 2.5 into 10 divided by 1 into 10, which is equal to 25 by 10. Okay, right. Now convert this 0.5 is equal to, we can write 5 by 10, right? See, the concept is, if the number is having one digit after the decimal point, you have to multiply both numerator and denominator with 10. Okay, if it is having two digits after the decimal point, you have to multiply both the denominator and numerator with 100. Okay, if it is having three digits after the decimal point, for example 0.175, you have to multiply with 1000. Okay, right. So now 0.175 is equal to 175 divided by 1000. Clear, students? Okay, now you can take these three numbers, given numbers 25 divided by 10 and 5 divided by 10 and 175 divided by 1000. Okay, you can see in the numerators you have 25, 5 and 175, and in the denominators you have 10, 10 and 1000. Okay, now look at the formula: LCM of numerators and HCF of denominators, right? So you have to find the LCM of numerators 25, 5 and 175, and HCF of denominators. So HCF of 10, 10, 1000, 1000. Clear, students? So now let us see how to find the LCM of 25, 5, 175 and HCF of 10, 10 and 1000. Okay, let's take 25, 5 and 175. Okay, 25, 5, 175. Right, students? So factors of 25 is 5 into 5 and here 5. And for 175, if you factorize 175, take 5 3 times 25, 5, 35. Take 5 again 7 times. So factors of 175 is 5 power 2 into 7. Right? Okay, now you can see the common factors you have to take for finding HCF. Right? So LCM of 25, 5 and 175. So take all the factors with highest power. So take 5 into 7, 5 highest power is 5 power 2 into 7, which is equal to 25 into 7, which is equal to 175. Okay, now we have found the LCM of numerators, which is equal to 175. Right? Now we will find the HCF of denominators. You can see here, by seeing you can say 10, 10, and for 1000 also 10 is the factor, right? So 10 is the common factor, 10 is the HCF. Okay, for all these things 10 is the factor, so we can take 10 as the HCF. Okay, so which is equal to 17.5. Okay, 17.5 is the LCM of 2.5, 0.5 and 0.175. Okay, clear, students? So what we are doing, you should be able to identify just by seeing these numbers. It is rational number and it can be written in the form of A divided by B, and you have to convert all the decimals into A divided by B form, and then apply in this formula, take all the numerators and find LCM, and take all the denominators and find HCF, and LCM of numerators divided by HCF of denominators will be the answer. Clear, students? Now I'll give you another formula. Okay, see, the question is asking about LCM. We have used this formula. Okay, in case the question is asking about HCF of the numbers, okay, the same formula will be upside down. Clear, students? So in place of LCM you have to put HCF. LCM of numerators will become HCF of numerators, and HCF will become LCM. LCM of numerators. Clear, students? Okay, so for the rational numbers, you can use this formula for finding the LCM, and this formula upside down, vice versa, will become the HCF formula. Okay, thank you, students. Okay, students, now let us see the practice question number 13. Okay, let's read the question. Find the least number which is divided by 16 leaves a remainder 6. When divided by 19 leaves a remainder 9, and when divided by 21 leaves a remainder 11. Okay, so a particular number, when it is divided by 16, you are getting a remainder of 6. The same number when you divide by 19, you are getting a remainder of 9. And the same number when you divide by 21, it gives a remainder of 11. Okay. So before you approach this question, you should understand there is a relationship between the divisors and remainders. Okay. Let us make an analysis of the divisors and the remainders given in this question. Okay. Divisor, remainder. Okay. See, when it is divided by 16, it gives a remainder of 6. And when it is divided by 19, it gives a remainder of 9. And when it is divided by 21, it gives a remainder of 11. Okay. You can see the difference between the divisor and remainder. Okay. 16 minus 6 is equal to 10, right? Let's write difference. And 19 minus 9 is also 10. And 21 minus 11 is also 10, right? You can see here the difference is same, right? 16 minus 6 is equal to 10, and 19 minus 9 is equal to 10, and 21 minus 11 is equal to 10, right? Now, let us see some example to understand better about the relationship between the divisor and the remainder. Okay, let's take 17 divided by 5. Okay, 17 by 5 is equal to 3 times, and the remainder is 2. Okay, now you can see the difference between this divisor and remainder. 5 minus 2 is equal to 3, right? If you add 3 with this 17, it will become divisible by 5 again. See, 17 plus 3 is equal to 20. 20 is divisible by 5, right? Let's see one more example. 49 divided by 5. Okay, 49 divided by 5 is equal to 9 times 5, 9 into 5 plus 4, right? 4 is the remainder. Okay, and see the difference. 5 minus 4 is equal to 1. Okay, the difference between the divisor and the remainder is 1. And if you add that difference with this 49, it will be 49 plus 1 is equal to 50. Again, 50 will become divisible by 5 here, right? So the difference between the divisor and remainder is coming 10 here. Okay, if you add this 10 with that required number, then it will become divisible by 16, 19 and 21. Clear, students? So the number which is divisible by 16, 19 and 21 is the LCM of all these three numbers, right? So the required number is 10 less than the LCM of 16, 19 and 21, right? So we can write here, so the required number is 10 less than the LCM of 16, 19 and 21. Okay, so now let us find the LCM of 16, 19, 21, and then we will reduce 10 from that number so that you will get the required number, right? Okay, let's take 16, 2, 8 times, again 2, 4, 2 by 2. So 2 power 4. Okay. So 16 factors is only 2 power 4. Okay. Coming to 19. 19 itself is the prime number. Okay. So there's no factor. 19 is equal to 19. Only one factor. And coming to 21. 21 take 3, 7 times. Okay, 7 is the prime number. So 21 is equal to 3 into 7. Okay, now let us take the LCM. Take all the factors with highest power. Okay, 2 power 4 into 19 into 3 into 7. If you multiply all these numbers, again we can write 16 into 19 into 3 into 7, which is equal to 6384. So the required number is 6384 minus 10, which is equal to 6374. Clear, students? So you should understand the concept between the divisor and the remainder. Okay, divisor and remainder gives you an idea. Okay, so the difference between the divisor and remainder, if you add that difference with that given number or the number which you are going to find, then it will divisible by all these three numbers. Okay, clear? Okay, now I'll give you one more exercise, okay, which you have to do on your own and check the answer. Okay, right. Find the number which is divided by 15. Okay, number which is divided by 15 gives a remainder of 6. Okay, so 6. Okay, take the 6. And when it is divisible by 22, leaves a remainder of 13. Okay, and when it is divisible by 27, gives a remainder of 18. Okay, the same model you have to work out. Okay, so when divided by 15, it gives a remainder of 6. When divided by 22, gives a remainder of 13. And when divided by 27, it gives the remainder of 18. Okay, so the answer for this question is 2961. 2961. Okay, so this question is for your practice. Okay, and you can do it by yourself to make your understanding better and to reinforce your knowledge. Okay, students. Now let us see the practice question number 14. Okay, if n is a natural number, then 2 into 5n plus 6n always ends with what? Right, students? It's a simple question. Okay, you will be able to answer very easily. So 2 into 5n plus 6n is equal to 2 into 11n. Okay, see, when you are multiplying with 2, the numbers will end with either 2 or 4 or 6 or 8 or 0. Okay, you can take your 2 table. 2 2s are 4, 3 2s are 6, 4 2s are 8, 5 2s are 10. It ends with 2, 4, 6, 8 and 0. And again it will start repeating. 6 2s are 12, 7 2s are 14, 8 2s are 16, 9 2s are 18 and 10 2s are 20. Right? Again it will repeat 2, 4, 6, 8, 0, right? So we can write, since the multiples of 2 ends with 0, 2, 4, 6 and 8, the number 2 into 5n plus 6n will end with the digits 0, 2, 4, 6 and 8. That's it, students.